The Atacama Desert is intriguing because it is the driest place on Earth. Deserts by their very nature are dry, but Atacama is unique. It's 50 times drier than Death Valley in California. And it's not because it's hotter. Atacama averages around 80 degrees Fahrenheit during the day, whereas temperatures in Death Valley regularly soar above 110. The search for what turned this strip of land from a regular desert into the world's driest place begins out on the open sea.
One of the curious things about the Atacama is that we actually see here penguins. Penguins obviously like cold water, and that's really confusing when you think of on shore we have really hot conditions. In fact, the temperature of the water here is about 55 degrees Fahrenheit, whereas on land the temperature is something like 80 degrees Fahrenheit.
These penguins were first described by explorer Alexander von Humboldt over 200 years ago. While traveling along this coast, he was puzzled by the huge variety of marine life. Measuring the temperature of the water gave him an explanation. It was 20 degrees colder than expected, perfect for sea life like penguins. Centuries later, meteorologists began to wonder if this chilly belt of water, called the Humboldt Current after the explorer, was the reason Atacama became the driest place on Earth.
The Humboldt Current comes all the way up from Antarctica, bringing with it cold water. And it is this cold water which creates this dull grey day that we see here with a fog overlying us.
It causes the air above it to cool, forming a thick bank of cold cloud and fog which clings to the shore. Hot, dry air descends at the tropics. Here, that hot air sits on top of the cold, heavy rain clouds, holding them down. Meteorologists call this an inversion layer. Trapped at 3,000 feet, the clouds can't rise up and shed their rain on the high-altitude desert.
The inversion layer prevents any moisture that may accumulate close to the sea from moving inland. So that is one of the reasons why this Humboldt Current actually contributes to the dryness of the Atacama Desert that we see just over there.
But is it this inversion layer, created by the Humboldt Current, that has turned Atacama into the driest desert in the world? In the desert's northern tip, in a desolate place called Quebrada Aroma, geologist Laura Evenstar is looking for clues to solve this riddle. She's trying to put a date on when the desert became so very dry. Other deserts, like the Mojave, don't get much rain, but when they do, it's dramatic. Storms bring heavy rains and flash floods. But not here, in the Quebrada Aroma, which is now totally dry. One way to date the last time there would have been enough rainfall to cause a flash flood is to try to find out how long the rocks have been lying there undisturbed.
What we have here is a miniature demonstration of what goes on if we start having large amounts of rainfall. So this is our rainfall here. And what we can see is that when we start raining on our desert surface, it will pick up the boulders and move them around. And then when there's no water here, the boulders just sit still and don't move.
The surface of Quebrada Aroma is strewn with rocks. so she's cracking them open to reveal evidence of exactly when water last flooded the landscape.
What we do is we have to knock a bit off and then we examine it and have a look at whether it's got a very dark colour, and hopefully we can be able to see some of the black minerals, which is what we're looking for.
The tiny black crystalline minerals are pyroxenes. They're crucial evidence because, like microscopic geologic clocks, their chemistry changes when exposed to cosmic radiation over time.
The sun is only producing a tiny bit of the radiation which will hit this rock. The majority of it is coming from all the stars you see in the night sky. What it does to the rock is basically just bakes it, a bit like a really bad suntan. So it just comes down, hits it, and cooks it.
As the rock gets cooked by cosmic rays, the pyroxenes break down and produce a gas called helium-3.
We can record how much helium-3 is within this rock, and the more we have, the longer that it has been exposed to cosmic or solar radiation.
Helium-3 gas is only produced in microscopic quantities. So Evenstar takes her samples to a lab 7,000 miles away in Glasgow, Scotland.
So what we do using a laser is we shoot the laser into one of the wells and vaporize our crystals. And that's releasing the helium-3. Then the helium-3 is going to go through all this complicated machinery, eventually run through the mass spectrometer.
By analyzing this data, she can figure out the last time the boulders were moved.
The oldest age sample we've actually recorded has been 23 million years. So what this means is that within certain areas of the Atacama Desert, these boulders have been sitting there and not moved by water for 23 million years. So the Atacama Desert is one of the oldest undisturbed surfaces in the world. These boulders were there before humans even started to exist. They are incredibly old.
Evenstar has discovered that there are places in the desert which have been bone dry for 23 million years. This date is a crucial clue in the investigation because it coincides with the birth of the Humboldt Current. South America was once joined to Antarctica, but roughly 25 million years ago, these continents split. A channel opened. Freezing water began to circulate round the pole and thundered north along the coast. This cold current formed an inversion layer, trapping coastal rain clouds and starting Atacama's slow transformation into the driest place in the world. But the Humboldt Current is not the only culprit. Ironically, the quest to find out how the desert became so dry comes up against one of the wettest places on Earth. On the other side of Atacama is the Amazon, but the heavy rainfall from the rainforest doesn't get anywhere near the desert. The reason why is in plain sight. Between the Amazon and the Atacama Desert lies the vast Andes mountain range. Geologic evidence suggests the Andes finally grew high enough some 10 million years ago to prevent any rain from reaching the desert. It's called a rain shadow effect, and it's the final factor which drove Atacama to become the driest place on Earth.